Mass uniformity of powder injection molded parts. Mass uniformity is the even distribution of density throughout the part. This is important because the less dense regions will cause the part to deform and not meet tolerance. An uneven distribution of mass leads to distortion, warping, and cracking. With an uneven density distribution, the part's flat surface will be distorted. The less dense region will experience more shrinkage at a faster rate than the more dense regions. Due to this shrinkage gradient, residual stress will build between these regions, making the part more likely to crack. Comparing the temperature distributions between the less dense region and high density region, we can see that the less dense region reaches higher temperatures faster. This is also why shrinkage is more rapid in less dense regions. This thermal gradient also contributes to warping. Here is a die cavity. As the mold fills from the gate, pressure decreases along the length of the mold, yielding less density and higher shrinkage. As you can see on the top left figure, during the molding process, it's likely there will be different density distributions over the part. After sintering, this causes the part to deviate from its original dimensions. Obviously, you want to design against short shot, flashing, and other common defects in the molding process, but also be cautious on the gate location. Acceptable maximum and minimum values depend on length of sintering and solids loading volume percent. For alumina, the probability of molding failure greatly increases for anything over 52%, but too little solids loading may affect jetting. To reduce shrinkage gradients, slow and long uniform heating should be applied. Careful not to over-sinter or the material's properties will degrade. Mass uniformity is a precursor to final dimensional uniformity. Ensuring mass distributions will reduce defective parts and increase quality and accuracy of finished parts. To ensure mass uniformity, design proper solids loading along with proper gate placement. The inclusion of a die cavity pressure transducer to regulate a uniform pressure throughout the mold, and following proper debinding and sintering procedures make for a happy customer.